In this video, we will learn about integrals. So, what are integrals? For that, you should know about derivatives. Let's say there is a function f of x, and derivative of function f of x is f dash x. And now suppose we know this function. So, this function is called derivative of the function f of x, and the process is called differentiation. Now suppose you know this function. So, क्या हम ये function find out कर सकता? Or I can say, is there any procedure to find this function जिसका derivative f dash x है? And this function is called antiderivative of this function. And the process of finding this function using this function is called integration. So this function is called antiderivative. This function is also called the integral of this function. So you can call this function antiderivative or integral of this function. So the calculus in which we find integral of the function is called integral calculus, and this integral calculus solves two problems. First, finding out the original function whose derivative is known. Means this function is known which is the derivative of this function. So using integration we can find this original function. And the second problem is finding the area bounded by the function. So if there is a function, let's say f of x, and we have to find area under the curve. So we can use this integral calculus to find this area. So these two problems leads to two form of integrals. First is indefinite integral and the second is definite integral. Using indefinite integral we can find this original function, and using definite integral we can find the area bounded by the function. So as I said, derivative of the function f of x is f dash x. So this function is derivative of the function f of x, and this function is integral of the function f dash x. The process of finding f dash x is called differentiation. Means the process of finding derivative is differentiation. So this function is called integral or antiderivative. And the process of finding this function is called integration or antidifferentiation. And how do we represent the integral? Integral of f dash x is f of x. So integral of f dash x with respect to x is f of x. ये है representation for integral. So integral of f dash x is f of x. So ये है symbol for integral. इसको read कैसे करते हैं? Integral of the function with respect to x is f of x. So यहाँ पे जो f of x है and f dash x है, we used to represent the function and its derivative with this notation. Now in integral we will use a little different notation. We will use derivative of f of x is f of x. Capital letter f of x and small letter f of x. So ये है derivative of this function. And similarly, integral of f of x is f of x. Integral of this function is this function. Integral of f of x is f of x. Now we'll discuss about an important parameter. For that, let's take some example. So we know that derivative of sin x is cos x, and derivative of sin x plus 2 is also cos x. क्योंकि ये तो डायरेक्ट फॉर्मूला है बट यहाँ पे प्लस है. सो डेरिवेटिव ऑफ साइन एक्स कॉस एक्स आ जाएगा एंड प्लस, ठीक है, डेरिवेटिव ऑफ 2 विच इज कांस्टेंट विल बी 0. सो cos x plus 0 is cos x. Similarly, derivative of sin x minus 4. Again, derivative of sin x is cos x, then minus derivative of 4 which is constant will be 0. So cos x minus 0 is cos x. So derivative of sin x is cos x, derivative of sin x plus 2 is also cos x, and derivative of sin x minus 4 is also cos x. So what will be integral of cos x? Integral of cos x with respect to x is sin x from the first equation, and from the second equation I will get integration of cos x is sin x plus 2, And from the third equation, I will get integration of cos x with respect to x is sin x minus 4. So from these three equations, I get these three integral. So यहाँ पर जो भी फंक्शन है वो क्या है, सेम है, बट जो भी इंटीग्रल मेरे को मिले वो डिफरेंट है. सो इफ यू फोकस इन दीज इक्वेशंस, यहाँ पे कुछ भी कांस्टेंट रहने से यही आंसर मिलेगा मेरे को, विच इज cos x. दिस कांस्टेंट कैन बी एनीथिंग, but the answer or the output will be same. So how do we represent all this function? So you can note that for any constant, I will get cos x. So यहाँ पे कुछ भी constant रहने से मेरे को cos x ही मिलेगा. So we represent every constant with this c. So c here is an arbitrary constant, which basically represents all the constants. So integration of cos x will be, integration of cos x with respect to x will be sin x plus c. Because for any constant, derivative of sin x plus c will be cos x. So integral of cos x is basically family of curves or family of antiderivatives. Because for different value of c, I will get different curves, and all these curves will be parallel. And the c is called constant of integration. This c is called constant of integration. So we have seen that derivative of f of x is f dash x. But this is incomplete, क्योंकि for any constant c, I will get this f of x. So integral of f of x with respect to x will be f of x plus c, क्योंकि derivative of f of x plus c will be f of x. Now let's discuss about this family of antiderivatives. For that, let's take an example. We know that derivative of x square is 2x, and integration of 2x with respect to x will be x square plus c. Now let's put different value of c. Let's say c is equals to 0. So integral of 2x will be x square plus 0, which is x square. Now let's take c equal to 1. So integral of 2x is x square plus 1. And let's say c equal to 2. So integral of 2x will be x square plus 2. And let's say c equal to minus 3. So integral of 2x will be x square minus 3. So for different value of c, we will get different functions. If we plot these functions, the first function was x square, and ये है y equal to x square का curve. ये है y equal to x square का curve. Next function was x square plus 1. Next function was y equal to x square plus 1. So ये है x square plus 1 and the previous curve was x square. So curve same रहेगा, but वो 1 units ऊपर रहेगा. So let's say ये है 0 and ये है 1. ठीक है. So ये है y equal to x square and ये है y equal to x square plus 1. मतलब सेम कर्व बट 1 यूनिट्स ऊपर. ठीक है. सिमिलरली जो नेक्स्ट फंक्शन था वो था x square plus 2. So x square plus 2 is the same curve but 2 units above the curve y equal to x square. So यहाँ पे जो 2 है इस पॉइंट से ये कर्व पास होगा. ठीक है. एंड सिमिलरली नेक्स्ट कर्व क्या था, x square minus 3. This curve will pass through minus 3, means 3 units below the curve y equal to x square. So 1, 2 and 3. So ये है curve y equal to x square minus 3. So here I have drawn 3 curve. ठीक है. So इस केस में c का वैल्यू क्या था, 0 था. इस केस में c का वैल्यू क्या था, 1 था. एंड इस केस में c का वैल्यू क्या था, minus 3 था. You can see all these curves are parallel. Or I can say at any point if you draw tangent, at any point if you draw tangent, these tangents will be parallel. So ये tangent let's say हम x equal to 1 में draw किए. ठीक है. x equal to 1 में draw किए. For every value of c, I will get different curves, and for all those curves, tangent at any point will be parallel. That means all these curves will be parallel to each other. So ये है geometrical interpretation for indefinite integral. So basically we get family of curves in indefinite integrals. Now we will see some properties of integrals. So integral of k into f of x with respect to x. So यहाँ पे जो function है यहाँ पे constant multiplied है. So similar to the derivatives, जो भी constant रहेगा उसको हम बाहर निकाल सकता. So this will become k into integration of f of x dx. जो भी constant रहेगा function के साथ में उस constant को हम बाहर निकाल सकता. And if functions are in sum, so integral of two functions in sum. So similar to the derivative, जो इंटीग्रल सिंबल है वो दोनों में अप्लाई हो जाएगा. सो इंटीग्रल ऑफ एफ ऑफ एक्स dx प्लस इंटीग्रल ऑफ जी ऑफ एक्स dx. सो जैसे ही साइन को अप्लाई करते हैं उसके साथ ही dx को भी दोनों फंक्शन में अप्लाई करना है. ठीक है. सो इंटीग्रल ऑफ एफ ऑफ एक्स विद रिस्पेक्ट टू एक्स एंड इंटीग्रल ऑफ जी ऑफ एक्स विद रिस्पेक्ट टू एक्स. एंड सेम प्रॉपर्टी इज एप्लीकेबल व्हेन टू फंक्शंस आर इन डिफरेंसेस. सो जब यहाँ पे माइनस रहेगा वी कैन अप्लाई द सेम प्रॉपर्टी. मतलब माइनस रहने से भी इंटीग्रल दोनों में हम अप्लाई कर सकता. सो दिस वाज अबाउट इंट्रोडक्शन टू इंटीग्रल्स. In the next video we will see some formulas, some basic formulas of integrals and solve some problems based on method of inspection. Thank you for watching this video.